Okay, so 4E, find the slope of a linear equation. And again, linear equation means they are linear because it makes a what? Straight line, a straight line. Good. So we can find what's called the slope, also known as the gradient, and also known as the change. So again, think of change, gradient, equate it with change because that's how you're going to interpret it. If you're asked to interpret it, we want to know how much change there is from one point to the next. Okay? So all of those are different words of writing slope. Now, the symbol for slope, however, is always the same. It's the lowercase letter m. So the lowercase letter m is in mathematics is always reserved for slope. You'll rarely ever see it used as a variable unless you're measuring something where m is the type of thing you're measuring. But in general for algebra, we reserve the lowercase letter m for slope. Okay? And what we're going to do is we're going to look at two different ways for finding slope. And the way you find slope is going to be determined by the type of information that you're given originally. And so the first one we're going to do is to find slope, again, m, when you have the graph of an equation. In other words, they've already drawn the picture of the equation for you. So you have the actual graph of that equation drawn for you. And if that's the case, then it's really easy to find slope by counting. So what we're going to do is we're going to use the counting method. Now to do that, we need to define slope in a way that will give us what to count and where. And slope is always defined, so let's go back and add one more up here, as rise over the run. There you go, good. Okay, so how much it goes up, but remember rise can also be negative, so not going up, but what? Going down. And then run could either be to the right if it's positive or to the left if it's negative. So you can have negatives here, so be very careful with it. Okay? All right. So if we define slope as rise over run, then we can use the counting method to find the slope. But that's only when you have the graph. That's the only time that this method works. So the first thing is choose any point on the line. It does not matter which point you choose as long as it's easy to measure. So you don't want to choose a point on the line that's between the lines. You want to choose a point where the graph lines are intersecting, right? So that it's easy to read. So make sure that it's easy to read. Now, most books will ask you to use what's called the y-intercept at this place. It really makes no difference, though, because sometimes the y-intercept is not as easy to read as some other point. It literally makes no difference, so I don't want you to get trapped into the idea of thinking that it has to be one particular point. It can be any point that's on the line, and you'll get exactly the same answer. So don't get trapped into thinking that the book said to do it this way, and that's the only way I can do it, okay? It's any point as long as it's easy to read. Second, choose a second point on the line. And I'll often abbreviate point as just PT after I've spelled it once. But again, it has to be a point that's easy to read. If you have to estimate, then the best you can do is get an estimate of the slope. We want an exact value, which is one reason why this is the least used and least effective way of finding the slope. The lines have to be very carefully drawn and very carefully manipulated to make this work. But these will be in your assignment. Third and last step, simply count rise over run from one point to the other. So all you're doing is counting. So there's literally no math involved in this. Now, when you count rise over run, however, you're going to get a fraction. And you have to remember the golden rule for fractions is that you always simplify them. So if I counted rise over run and I got 4 over 2, you cannot leave it as 4 over 2. Because 4 over 2 literally means take 4 divided by 2, so your slope would be just plain old 2. Right? Also, if you went down and then left, that would be a negative over another negative. And what does a negative divided by another negative make, guys? A positive. So you would need to do the sign as well. Okay? So you do have to simplify the fraction if you can. If you counted it out and it was 3 over 4, then 3 over 4 is as simplified as it can get. Do not change it to a decimal. That will not help you ever. Okay? So do not convert it to a decimal. Always leave it as a fraction. Because as a fraction, you have it as rise over run, which is the usable form. Okay? If you have it as decimal, you'd have to then convert it back to a fraction in order to use it. Okay? Now, so we're going to take a look at some examples of that in just a moment, but first we're going to go through the second method, the second process for finding slope. Because you're not always going to be given the graph, and you're not always going to want to draw the graph of a line if all you're looking for is the slope. You may be given some more information. To find m, and again, what does m stand for? Slope, gradient, whatever word you want to use, yep, or change. To find m, when you are given 2 ordered pairs from a line. So in other words, they haven't bothered to graph this for you, but they're telling you that the point 1, 2 and the point 3, 7, for example, are on the line. You're given 2 ordered pairs. Now, this is a very simple process. There's a formula for finding slope. What you're going to do is you're going to use what's literally called the slope formula. And it's easy to use. The mathematics in it are incredibly easy, but it is also one of the most disturbingly misused formulas because you don't pay attention to what you got and you don't stay focused and organized. It looks so easy, you just think you can just bang in the numbers and go. But you've got to be really careful to put the right number in the right spot. And you've got to be really careful to watch out for your signs. So here's the formula itself. M is equal to y sub 2 minus y sub 1, and I'll explain what that means in a minute, over x sub 2 minus x sub 1. It's y's on the top because slope is defined as rise, and y tells you how much you're going up or down, right? And x is on the bottom because the bottom of the slope is run, and that's how far you go right or left. So those are your x values, right? So it's exactly reversed from an ordered pair. Your y's are on top and your x's are on the bottom. And if you know anything about change at all, okay? So let's say that you're 17 years old now. right? And I want to know how many years ago it was that you were 11, then you would take your 17 years old and subtract the one that happened before to find the difference, right? To find the change. Change is always the newest value minus the old value, right? So, and we looked at some of that when we were dealing with the amounts of change when we were doing the financial sections that we did. And that's why it's y sub 2 minus y sub 1. Those little, so y sub 2 is literally read as the second y value. So anytime you ever see those little subscripts, those little numbers at the bottom, it just means the first one or the second one or the third one or the fourth one or the 25th one. It doesn't make any difference what number it is. It's just that value. So y sub 2 literally means the second y value, which means that it's not coming from the first ordered pair that they give you, but what? The second ordered pair that they give you, right? Okay. So if they give me ordered pairs A, comma B, and C, comma D, again, I'm not using numbers here, this is just general form, and I'm asked to find these, this is the first one, and this is the second one. So this would be your first x, this would be x1 and y1. This would be x1 and y1. This one would be x2 and y2. It simply means x from the first point, y from the first point, x from the second point, y from the second point. Okay? So it's very straightforward. All right. So that's all the background we need. Let's talk about how to use it. Okay? So the first step in using it is label your x1, y1, and x2, y2. If you don't take the time to label these, and again, you don't have to do that. What I usually do is this. These are the ones. These are the twos. You don't have to get too carried away, but you need to make sure you're doing something physically to set it in your brain that this one is the first ones to use, this one's the second ones to use. Because these values are going to go into the formula in front of the others, right? Because you're measuring change, so you start with the second one minus the first one. Second, write down the formula. I know you don't want to have to write down anything that you don't have to, but your job here is to get this done and get it done correctly. And if you just write down the formula, it will make your life easier. And I'm not even talking about writing down the formula and then plugging things in. Here's what I mean. It's a big fraction, right? With one value minus another value in it. I'm not going to even put any values. So write down the formula without any values in it. In other words, you're turning it into a form. Have you ever filled out a form where they want your name, address, whatever?
Yes.
How easy is it when they tell you exactly where to put everything?
So easy.
Yeah. So if you just do a form, sorry, no autofill on these. If you just do a form for this, then you're going to know what it's supposed to look like and you can put things in properly. Okay? Then, substitute the values from the points into the formula. And you've already taken the time to label them 1 and 2, so that has put it in your brain that they need to go in a specific order. Now it's backwards, right? The 2s are going to come first, but don't worry about that. And then all you have to do is simplify. Simplify is that all-purpose math word that means to do the math, right? And when you're simplifying a big fraction, you always do everything in the top of the fraction, then you do everything in the bottom of the fraction, and then you see if they will divide. Okay? And when you're simplifying here, I will tell you that the biggest mistake that students make when they're working on these is signs. Because we have a minus from our formula, and so if I put a negative after that minus, what does minus a minus become? Positive, right? So that minus in the formula is going to turn any positives into negatives. The minus in the formula is going to turn any negatives into positives, right? And that's one reason why I like for you to write it down before you start putting numbers in. Okay? And that's going to give us our slope if we know 2 points. So I'm going to stop the recording, then we're going to pop over to the book and start looking for some examples of these. So you have your notes in front of you. You'll use your notes and answer questions.